going to go over our daily goals and agenda, our essential question for the day, and one of our essential questions for this unit is, how do scientists use math to analyze chemical reactions and predict outcomes? So today we're going to have a quick pre-assessment quiz, so that way you'll be able to see where you were before and after the lesson. It's only a few points, so don't worry too much about it. Just do your best. Then we're going to have a quick lecture to introduce our topic of the day, stoichiometry. Then we will practice doing stoichiometry with a partner. I'll send you some questions from the book that you can work from. Then we'll be doing a concept map, and we will have an exit ticket at the end of the day. For our homework, you will be finishing whatever you don't finish for the concept map, and you'll be completing questions 6 and 7 from page 357, and questions 17 and 18 on page 363. So the pre-assessment will be about 5 questions. It'll only be 5 points. You have 7 minutes. Don't feel rushed. Whatever you don't get done, it's not a big deal. Okay, everybody, pass up your quizzes and we will get started on our lecture. So we're going to introduce stoichiometry today. And so what is stoichiometry? So stoichiometry is the study of quantitative relationships between the amounts of reactants used and the products formed in a chemical reaction. It's based on the law of conservation of mass. Does anyone remember what the law of conservation of mass is? Yes, that is correct. So it's when matter can neither be created nor destroyed. In a chemical reaction, the mass of the reactants will equal the mass of products, therefore observing the law of conservation of mass. So does anyone know how products are created if the law of conservation of mass must be followed? Meaning they don't just appear. So how does that happen? Yes, bonds are broken, then reformed to create a new arrangement of atoms. Yes, that's correct. Next we'll be watching a video introducing stoichiometry. They give a lovely example using grilled cheese. So that'll be fun. Okay, so does anyone have any questions about the video so far? Perfect, we will move on then. So it's important to know why we're learning about stoichiometry, because if you don't know why you need it, why would you want to learn it? So for chemistry, in particular this class, assuming you don't go any further, it is a fundamental topic that is used in most aspects of the subject. It is used to make useful predictions about chemical reactions, and you can predict the amount of products you will get or the amount of reactants you will need to get a certain amount of products, as seen in the video, where they showed us that they wanted 7 full grilled cheeses, and so we had to figure out how many slices of bread we would need. If you were to become a scientist or pharmacist, you would also need to use stoichiometry. Pharmacists need stoichiometry to mix medications and understand how they work and how others need to use it. Scientists use stoichiometry to reduce the cost of buying chemicals as well as the amount of waste. In life, the basic idea of stoichiometry is used in cooking, converting between units like Fahrenheit and Celsius, and knowing how much fertilizer to use in your garden, things like that. Ratio is a ratio between the numbers of moles of any two substances in a balanced chemical equation. A ratio is basically comparing two numbers. So, for example, we're going to look at the equation for aluminum and bromine mixing to create aluminum bromide. So first we need to create the balanced equation. Can anyone tell me how to balance this equation? Yes, that's correct. So it's 2 moles of aluminum and 3 moles of bromide to create 2 moles of aluminum bromine. So a mole ratio for aluminum and bromine would be 2 moles of aluminum to 3 moles of bromine. So, and then can anyone tell me what the mole ratio for aluminum and aluminum bromide might be? Yes, 2 moles of aluminum to 2 moles of aluminum bromide. So what other mole ratios can you make for this chemical reaction? Okay, yes, that's correct. There are 4, but can anyone tell me what they are? Almost right. So we can compare bromine to aluminum bromide, aluminum bromide to aluminum, and aluminum bromide to bromine. So in total, you have 6 mole ratios for one balanced equation with 2 reactants and 1 product. So the steps to use stoichiometry are as follows. First, you need to write a balanced equation. You need the balanced equation because it's really important for you to know the coefficients, and as you'll later see in the examples. Then you need to identify the knowns and unknowns. Do you know how many moles of the reactant or product you have? Do you know what you're looking for? Then you need to use conversion factors. So the conversion factors you can use are the mole ratio, which converts moles to moles, the molar mass ratio, the molar mass conversion factor, which does moles to grams. Then we have molarity, which is moles to liters of a solution, and molar volume, which is moles to liters of gas. And then all you need to do is check your answer to make sure everything's correct. So next we're gonna do example problem 12.1, and we're going to be verifying the law of conservation of mass. So the problem is the combustion of propane provides energy for heating homes, cooking food, and soldering metal parts. Interpret the equation for the combustion of propane in terms of the representative particles, moles, and mass. And then we need to show the law of conservation of mass is observed. Okay, so for example 12.1, so propane is C3H8. So first we're going to write a balanced equation, which is this. So propane reacts with oxygen to create carbon dioxide and water. Our unknowns are these. We want to know the equation in terms of molecules, in terms of moles, and in terms of mass. So molecules are indicated by the coefficients. So when we look at the coefficients, we see that there's 1 molecule of propane, 5 molecules of oxygen, 3 molecules of carbon dioxide, and 4 molecules of water. Okay, so the moles also are indicated by the coefficients. So basically we have the exact same breakdown. We have 1 mole of propane, 5 moles of oxygen, 3 moles of carbon dioxide, and 4 moles of water. But to find the mass, we need to use the conversion factor, molar mass, as we just saw in the PowerPoint, which goes from moles to mass. So this is the equation you would use when you use the conversion factor. So you're going to look at the moles of the reactant or product, and then you're going to multiply it by a ratio of grams of the reactant or product over 1 mole of the reactant or product. And you'll get the mass in grams of the reactant or product. So we're going to look at the periodic table, and we're going to find the molar mass of propane. So can anyone tell me how to find the molar mass of propane? Yes. So you're going to count how many carbons there are, and then you're going to add up how many of the mass of how many carbons there are. So the mass of carbon is 12, so you're going to multiply it by 3. Then you're going to do the same thing for hydrogen, and you're going to come up with a total of 44.09 grams of propane per mole of propane. So you're going to complete the conversion. So for 1 mole of propane, there is 44.09 grams of propane. We are going to continue doing the exact same thing for the rest of them. So as we can see here, we have 2 oxygens, and so the molar mass of oxygen is 32 times 5 moles is 160 grams of oxygen. And then we have 132 grams of carbon dioxide and 72.08 grams of water. So in order for us to show the law of conservation of mass, we must then have the mass of the reactants equal the mass of products. So you just need to add up on both sides the mass of the reactants and the mass of the products. As they are equal, the conclusion is that the law of conservation of mass is observed. Next, we're going to practice mole-to-mole conversions. So we're going to use the same steps as we used last time. So we'll be writing a balanced equation, identifying the knowns and unknowns, lining up the conversion factors, and checking our answer. So in this question, we're going to look at the combustion of propane, which is exactly what we did in the last example. But in this time, we're asked how many moles of carbon are produced when we have 10 moles of propane being burned in excess oxygen in a gas grill. So excess oxygen means that we won't be running out of it, so we don't need to consider it a factor in this problem. We're going to start with our balanced equation. So we're going to start with our balanced equation and our knowns and unknowns. So the equation is the same as last time. We have 1 mole of propane, 5 moles of oxygen, creating 3 moles of carbon dioxide and 4 moles of water. So our known is the moles of propane, which we have 10, and our unknown, which is what we're solving for, is how many moles of carbon dioxide that creates. So first we need to look at the molar ratio, which relates carbon dioxide to propane. So we have 3 moles of carbon dioxide to 1 mole of propane. So the top one is the reactant or product that we are solving for, and the bottom one is what our known is. So this is the conversion factor. The ratio is the conversion factor for moles to mole. So next we need to find the unknown. So we're going to use the conversion factor to find out how many moles of CO2. So we see that the bottom here and this one here cancel out. So we only have to worry about carbon dioxide in the answer. So 10 times 3 is 30. So can anyone tell me what this means? Yes. So we basically have 3 times as much carbon dioxide being produced as propane being used, which means burning 10 moles of propane produces 30 moles of carbon dioxide. Okay, so we will be looking at one more example today. We'll be looking at example 12.3. We're going to do mole to mass conversion. So we're going to use a new equation, and we're going to determine the mass of sodium chloride or table salt produced when we have 1.5 moles of chlorine gas reacting vigorously with sodium. Okay, so first we're going to find the balance equation. Can anyone tell me what that is when sodium and chloride react to create table salt? That's correct. Our balanced equation is 2 moles of sodium with 1 mole of chloride to create 2 moles of sodium chloride. So what's our known? Yes, we are starting off with 1.25 moles of chlorine. And what are we looking for? What's our unknown? Yes, we are looking for the mass of sodium chloride. So we're going to be looking for grams. So can anyone give me a guess as to what our first step would be? Not quite, no. We are going to first look at the mole ratio to relate sodium chloride to chlorine. Can anyone tell me what that is? Yes, correct. Okay, we have 2 moles of sodium chloride to 1 mole of chlorine. From here, does anyone know what our next step should be based on what we did last time? Yes, we want to first find the moles of, yes, salt, sodium chloride. So to do so, we have to find the number of moles produced. So we're going to do this equation, and we get 2.5 moles of sodium chloride. Does anyone know what to do next? Yes. Okay, so we are going to use which conversion factor? Yes, we're going to convert using molar mass. So we're going to use it to solve for the unknown. So we're going to take the molar mass of sodium chloride, which is 54.44, over 1 mole of sodium chloride, and we're going to multiply it by 2.5 moles. Yes. And we're going to get 146 grams of sodium chloride, because the moles cancel out to leave only grams left. The moles cancel out to only leave grams left. So we know that 146 grams of sodium chloride are produced when we use 1.25 moles of chlorine. Mass-to-mass conversions until tomorrow, just so that we have time to do the rest of our activities for the day. So we're going to go on to our partner activities. I want everyone to scoot closer to their assigned partner, and we'll get started. You'll need to grab out a sheet of paper, a pen or pencil, and you will each do your own paper and turn in your own work, but you can work together to do so. So the practice problems are on these pages and these numbers. And we have a bonus problem on page 362 in case you want to try it out. Okay? I'll be walking around, and if anyone has any questions, just raise your hand or come up to me and we'll talk. Okay, everyone get in their groups and let's get started.